All right, welcome back again to Number Sense Academy, and today we're going to dive into another important topic: fractions. Everybody's favorite mathematical topic: fractions. So, we're going to look at different aspects of fractions. We're going to talk about common fractions, what they are. We're going to talk about improper fractions. So, actually, before we get there, let's start with proper fractions. Then we'll look at improper fractions. And then we'll also look at mixed fractions. So we're going to cover quite a bit about the basics of fractions. And then we'll get into, in another video, we'll talk about how to do operations with fractions, like adding and subtracting fractions. We'll talk about multiplying and dividing fractions. And then we'll talk about converting fractions to decimals, to percents, and how to write them interchangeably. But for now, we're just focusing on these main aspects of fractions. So let's dive into this. So a common fraction is used to show a part of a whole. All right. So imagine you have a pie, or say you have two pies. You have a pie, and your friend has a pie. All right. So you both have a whole pie, same size, but the difference is that you can decide how you want to split these pies up. So this is me. So I'm going to split my pie up in four pieces. All right. Same pie, same size. I just choose to split it in four pieces. My friend, on the other hand, he's going to choose to split his pie up in six pieces. Okay, so his pie is split up in six pieces. Mine is split up in four pieces. So same whole, just different parts. So I can, it normally takes me. I split the pie up in four ways because I'm going to finish it in 4 days. My friend splits the pie up in six ways because he's going to finish it in 6 days. One slice a day over 6 days, one slice a day over 4 days. So I could take any amount out of this to represent a part. So say on day one, I take one slice, right? So in other words, I've taken one of the four slices. My friend, on the other hand, decided that, you know what, I know I'm supposed to split it up for use it over 6 days, but I feel like having two pieces today. So he takes two of the six parts. All right. So this tells us some information about how fractions are written and what they mean. So let's look at that a little bit more. So whenever you write a fraction, you normally write a fraction are normally written in a very specific form. So we know that they're fractions, and we write it as a over b. So a, this is called the numerator, all right, and b is called the. I want this to be consistent. Let's make this blue. B is called the denominator. The numerator tells us, well, let's start with the denominator. This tells us the total number of parts. All right, so if we go back to the previous slide, I split my pie up in four total number of parts. That's why I had four on the bottom. My friend split up his pie in 6 total number of parts. I ate 1 pie, so this represent, the numerator then represent a part or parts of the total. All right, so I could consume parts of the total up until the total amount, up until the whole pie. So in this case, I had 1 of the 4 parts, so I wrote it as 1 over 4. My friend had 2 of the 6 parts, so we write that as 6 or 2 over 6. Okay, so that's the basics about fractions. So now let's look at some other components of fraction. So I mentioned the idea of a proper fraction. A proper fraction simply means that the numerator, so the number on top, is less than the denominator. So if you see a fraction where if we have a over b and a is less than b, then this is automatically a proper fraction. So example, 3 over 4. 3 is less than 4. That's a proper fraction. 199 over 2,000. 199 is less than 2,000. Okay, so these are examples of proper fractions. Then we have improper fractions. And an improper fraction simply means that the numerator is more than the denominator. Okay, so the numerator is more than the denominator. So in this case, we have a over b, but a is greater than b. So 15 over 5, 2010 over 2001. These are examples of improper fractions. Okay, now there's a couple more properties of fractions that I think is useful that we should talk about. So the numerator, the number on top, in more technical mathematical terms, we normally refer to this as the dividend. Okay, the dividend. So that's the number that's being divided into, the dividend. And then the denominator is referred to as the divisor. This is the number that we're using to divide into the dividend. And that tells you another important property of fractions, which is interesting. So we know that if I have a over b, a tells me the number of parts, right? And b tells me the total number of parts. But this b is also being divided into a, so I could write fractions as a divided by b. That's one way of writing a fraction, right? So if I'm dividing a proper fraction, b is going to be bigger than a. If I'm dividing an improper fraction, a is going to be bigger than b. And once you think about those things, you start seeing the implications of what this means when you come to improper fraction and proper fractions. And we'll get into those in a bit. So a third fraction, so we have proper fractions and we have improper fractions. We also have mixed fractions. And mixed fractions is the sum of a whole number or a natural number and a proper fraction. So it's the sum of a whole number and a proper fraction. And we normally write a mixed fraction in this form. So we have A and then B over C, right? So the B over C, this is, or the A, this is the whole number. And we write it a little bit bigger so it stands out. And then B over C, this is your proper fraction. Okay? And we said that that's a sum, right? So this is actually the same as A plus B over C. And normally we expect that A is greater than 0, right? In real, if we're dealing with actual quantities or, parts of real things, then A should be positive. But if, we're just dealing with fictitious things, or we're just having an equation for the having an equation, or there's a relationship that we're modeling, then A could be negative. So maybe we should say that A is not equal to 0. Right? Because if A is equal to 0, then it's no longer a mixed fraction. It's just 0 plus a proper fraction, which is just a proper fraction. Right? So we're just going to say that A is not equal to 0. Depending on the context, we could have integers for the whole number. But if we're dealing with real things, cars, people, pencils, then we're going to have a positive number. So a mixed fraction can be expressed. A mixed fraction can be expressed as an improper fraction. Which means that if you have an improper fraction, you could also write it as a mixed fraction. For some people, an improper fraction won't make sense, but a mixed fraction will make sense. So I'll give you an example. If I write 15 over 5, well, that's an improper fraction because 15 is bigger than 5. But as a mixed number, it's just 3. Right? 3 and 1 over 1. No, it's not. Yeah, no, it's not 1 over 1. Sorry, take that out. Okay? Maybe 3 and 0 over 1. Yeah. So that's a mixed fraction. And it can be written as, or an improper fraction written as a mixed fraction. That makes more sense. Or maybe a better example would be if I have 3 over 2. Well, it doesn't really mean much, but that's equal to 1.5. Hey, give me 3 over 2 of your pizza, or 3 halves of your pizza. Like what? Okay, well give me 1 piece and then a half of the next one. Yeah, that makes more sense, but I won't give you that much. Okay, so a mixed fraction can be expressed as an improper fraction. So how do you do that? So remember, a mixed fraction, we normally write it as A times B over C. How would we express this as an improper fraction? So it's a formula and it's simple. So we're going to keep this C as our denominator. That doesn't change. We're going to take the denominator, multiply it by the whole number, and then add the numerator. And this will ensure that we end up with a bigger number on top than the bottom, because we're multiplying it by a factor and then adding something to it. It's going to be bigger than the number on the bottom. Okay, so let's quick example. If I have 3 2/3 and I want to convert that to a improper fraction, and there'll be reasons why you want to do this. If you're dividing fractions, if you're subtracting fractions, it's a good idea to convert your mixed fractions into improper fractions. Just easier to do. So remember, so the numerator or the denominator is 3, so that stays. Then I'm going to take the denominator, multiply it by the whole number, which is 3, and I'm going to add the numerator, which is 2. So this is equal to 3 times 3, which is 9, plus 2, which is 11. So I end up with a 11 over 3. And that satisfies the requirements for an improper fraction, where the numerator is bigger than the denominator. Now, just like how a mixed fraction can be expressed as an improper fraction, we can express an improper fraction as a mixed fraction. Mixed fraction. So let's for the sake of consistency and make it easy to understand. So let's start with 11 over 3. Okay, we already know that came from 3 and 2/3 from the previous example. So let's see how we can make this equal to 3 and 2/3. So remember, this is not just a denominator, it is a divisor. And this is not just a numerator, it is a dividend. So what I'm going to do, I'm going to turn this into a division situation. So I'm going to take 11 and I'm going to divide it by 3. All right, so this is how I do long division. Some people might have different ways of writing it. So the first question I'm going to ask is, how many times can 3 go into 1? Not enough. We're going to end up with a decimal. So I'm going to use 11 because 1 wasn't big enough. So 11 should definitely be big enough. How many times does 3 go in 11? Well, it goes in there 3 times. Right? So what's that actually equal to? 3 times 3 is 9. If I subtract 9 from 11, I end up with 2. Now, I'm going to stop here because if I continue, now I'm going to be converting decimals. I'm going to be converting this this improper fraction into a decimal. I don't want to do that. I want to convert it into a mixed fraction. Okay? So I'll stop here. As soon as I go through all of the digits in the dividend, I will pause my operations. Remainders are okay because they actually have value. So I have a remainder of 2. I have a quotient of 3. So what happens? This 3 is my whole number. All right? This remainder, this is the remainder. This becomes my numerator in the proper part of the proper fraction part of the mixed fraction. And then this 3, which was never changed, it's still the divisor. And then, so this divisor remains the divisor, so it's still the denominator. All right? So now my final answer becomes 3. The numerator is 2 for the proper fraction part, and the divisor is still 3. So I have 3 and 2/3. So I'm back to where I started, which is good. All right, so remember that if you want to convert improper fraction to mixed, you set up your operation. The quotient becomes the whole number, the remainder becomes the numerator, and the divisor remains the denominator. Okay, so let's talk about one last thing before we jump into a few examples. And this is important when it comes to fractions. You might be familiar with the term equivalent fractions. All right. This simply means that you change the terms of the fraction or a fraction without changing its value. Without changing its value. So there's 2 ways that could be accomplished. You could get equivalent fractions in higher terms. All right. And this simply means that you multiply the numerator and the denominator by the same value. All right? And you could get equivalent fractions in lower terms. And this means that you divide the numerator and the denominator by the same value. Now I'll do a quick example to show you how this works. We have some examples coming after this, but I'll do a quick example just to demonstrate this. So if I have 2/3, it says I could raise this to higher terms, but I'm not changing the value. So imagine I multiply both of these by 3/3. Okay, so follow the rules of multiplication. Whatever I multiply the top by, I got to multiply it by the bottom. That's what the rule says. You multiply the numerator and the denominator by the same value. So I could just write it as 3/3. And what I end up with is 3 times 2 is 6, and 3 times 3 is 9. So I haven't changed the value. I've only raised it to higher terms. Here's another reason why you know that you've only raised it to higher terms and not changed the value. Because you multiplied by 3/3. 3/3 is just 1. 3 divided by 3 is 1. So you essentially multiply 2/3 by 1. And we know that when you multiply a number by 1, it's just that number. So we multiplied this fraction by 1, so we haven't changed the value. We just change it to higher terms. And we need to do this for various reasons, like adding fractions maybe, and some other reasons. Okay? And we'll get into that in another video. So likewise, if I look at in lower terms, say I have 8/10, and I want to reduce this to lower terms, I'm going to divide both terms by 2. So even if I write it as divided by 2/2, if you follow the rules of division, you're going to change this to a multiplication sign and then flip these two. But it doesn't matter if you flip them, you're still going to end up with 2/2. So we'll just leave it. So when I divide, I'm going to end up with 4/5. So just like in the previous example, 2/2 is equal to 1. So I essentially divided 8/10 by 1. Essentially. And you know that when you, same rule as before, when you multiply a number by 1, it's itself. When you divide a number by 1, it still remains itself. Okay, so when we change things to higher terms and lower terms, we're not changing the value. The value remains the same. Same value. No difference in value. We're just changing the terms. And this is useful to help with some operations. Okay? All right, so let's jump into some quick examples. We have a handful here just to kind of shore up and firm up the knowledge that we just gained from doing these fractions. So I'm going to write down a set of fractions and we're going to identify them. So the first one is 1/2. What kind of fraction is this? Well, this is a proper fraction. Okay, this is a proper fraction. What about 5/4? Well, this is improper because the number on top is bigger than the number on the bottom. Okay, and we have 3/4. Again, this is proper. The number on top is smaller than the number on the bottom. And we have 13/22. This is also proper. And what else do we have? We have 4 3/9. Well, this should be pretty straightforward. This is a mixed fraction because we look at it, we got a whole number and a proper fraction. sitting right beside it. Okay, so that was just a quick exercise to identify the different type of fractions. So, whenever you see these fractions in your textbook or on a piece of paper or on a notice you get from your bank, if they use fractions, then you should be able to tell what's happening there. Okay, let's look at some other examples. We have 4 over 7, and we're going to raise by a factor of 2. Okay, so this means that we're raising it to higher terms. So what do? I have 4 over 7, and I'm going to multiply by 2 over 2. So both the top and the bottom have to take the same factor. So this becomes 4 times 2 is 8, 8 over 14. Okay, what if we were to take that same 4 over 7 and raise it by a factor of 3? So now we end up with 12 over 21. All we're saying is that these values are the same values. They're just raised to a higher term. But 4 over 7 is the same as 8 over 14, is the same as 12 over 21. If you have a cake and you split it into 21 parts and you take 12 of it away, and the person beside you has a cake, they split into 7 parts and they take 4 away, and the third person has a cake and they split into 14 parts and they remove 8, you've all essentially removed the same amount of your cake. Okay, what about reducing to lower terms? So if I have reduce to lower terms, if I have 8 over 12, all right, if I look at it right away, and we'll get into this in another video, I want to be able to reduce by the biggest number possible. I need the greatest common factor because it has to be the same number on the bottom as on the top. I got to divide both by the same factors. Right? That's what we have to do. So in this case, whereas we tell you what to raise it to, we normally don't tell you what to reduce it by. You have to figure it out. So I know that 4 works, but I also know that these both are even numbers. So I'm going to reduce by 2 to begin with. And I got to do it for both. And we're going to see that if you don't take the biggest common factor right away, then you're going to have to do it a couple times. So 8 divided by 2 is 4, and 12 divided by 2 is 6. So because both of these are even, I can still take it a step further, and I'll divide by 2. And I'll see where that gets me. So now I end up with 4 divided by 2 is 2, and 6 divided by 2 is 3. So this is as far as this goes. So I've reduced it to the lowest terms possible. All right, let's look at another example. So this one I'm going to, if I have 13 over 51, well, I know that the only number that works to reduce the 13 into 51, not 51, sorry, 52. Let's write that properly. Is 13. So I divide both by 13, I get 1 over 4. So 13 is a quarter of 52. So 13 over 52 is the same as 1 over 4. All right? So that's reducing the lower term. So you have to know, you have to have some kind of inclination as to what numbers works, and in order to do your reducing. All right, let's do a quick example of converting to improper fractions. So convert to improper fraction. So if I have 5 and 4/9, I want this to convert to an improper fraction. And remember, I keep the denominator as it is. I take the denominator, multiply it by the whole number, and then I add the numerator. So 9 times 5 is 45. 45 plus 4 is 49. And I end up with 49 over 9. Okay, pretty straightforward. It's very straightforward. Okay, and then lastly, we will convert a improper fraction to mixed fraction. Right? So what do we got? So we have 18 over 4. So remember, this becomes, I'm going to take 18, I'm going to divide it by 4. So 4 into 18, 4 into 1 doesn't work. 4 into 18 is 4 times. 4 fours is 16. I subtract, I end up with 2. So I'm going to stop there. I have nothing else to work with on this side, so I'll stop here. So this becomes my whole number is my quotient, so that's 4. My remainder is my numerator, so that's 2. And my divisor becomes remains my denominator. Okay, but when I look at this, I notice that this 2 over 2, 2 over 4 is they're even numbers, so I could reduce them by dividing by 2. All right, so I'm going to divide that by 2, and I'm going to divide this by 2. Pardon the ugly writing. So I end up with 4 and 1/2. Now a thing to keep in mind is that if you look at this number, 8, a number that ends with an even number is an even number. So the 18 and the 4, these are both divisible by 2. So I could have reduced this early, and that's always a good idea, because what if you had like a really long number, like say 1800 over 400, right? You don't want to go through all of this dividing 1800 and 400. If you could just trim it down by dividing everything by 200, then you end up with 9 over 2. And then it's just very simple math, probably one step. Because the more digits you have over here is the more values you get in the quotient. Might not affect the remainder as much, but the more digits you have here, you have this big number to deal with. We could trim it down by first reducing and making this 9 over 2. So I'll show you what I mean. If 18 over 2, I divide everything, or 18 over 4, pardon that. I have 18 over 4, and I divide everything by 2 over 2, I end up with 9 over 2. This is much easier to convert. So now I have 9 divided by 2. I have 2 goes into 9 4 times. 4 2's 8. There's 1 left over. So now when I write this out, I got my whole number. So I have 4. My numerator, right, which is 1. And then my divisor, which is 2. So I still end up with 4.5. But I saved myself a little bit of headache. Like I said, if you had a really big number here and they were divisible, it's just better to get the reduction out of the way. Change it to a lower term first, and then do your conversions. All right, thank you. That's it for fractions.